Hi, my name is Emma Luna, and I am pursuing GLD in undergraduate research this semester. For my research, I decided to explore the antimicrobial properties of 5 different hydrosols and 5 different essential oils against skin microbiota. Essential oils and hydrosols are produced at the same time through steam distillation, which is the process of extracting the oil and water vapors from the plant's leaves. The vapors are then condensed and collected into a separator. In the separator, there's going to be 2 layers. The top layer is the 100% essential oil, and the bottom layer is the hydrosol, which is primarily water and micro droplets of the essential oil. The 5 essential oils and hydrosols used in this research were tea tree, lavender, rose, geranium, and neroli. Since lavender and tea tree essential oils already have known antimicrobial properties, I have hypothesized that their hydrosols will as well, with lavender hydrosol showing the most antimicrobial properties. In this research, I actually ran 2 experiments. The first experiment, I did the zone of inhibition. So I took 5 different microbes. The microbes were S. aureus, E. faecalis, B. subtilis, E. coli, and C. albicans. Looking at figure 1, you can see the average zones of inhibition for the hydrosols. We do have water on the end as a control. Looking at figure 2, this is the average zone of inhibition for all of the essential oils, and you will notice that there are 2 tea tree oils and 2 lavender essential oils. We have a tea tree 100% essential oil and a lavender 100% essential oil, because both of those you are able to put directly on your skin and not cause any harm. The second experiment I ran was a total colony count experiment, where I was able to collect samples of skin flora before and after I put on the lavender hydrosol. I plated those samples on TSA plates, put them in the incubator for about 48 hours, and after that I counted all of the colonies on the plate. In figure 3, it shows you the average before putting on the hydrosol and the average after putting on the hydrosol. Looking back at figure 1, I concluded that my hypothesis was not supported by this data. Geranium was actually the hydrosol that showed the most antimicrobial properties. Looking at figure 2, the tea tree oil and the lavender, both at 100%, definitely had the most antimicrobial properties, which we already knew. And by comparing those 2 samples to the rest of the graph in figure 2, we can see that if you want to benefit from the antimicrobial properties, you would have to use 100% solution. And then comparing figure 1 to figure 2, we can still see that the tea tree 100% essential oil and the lavender 100% essential oil still have the highest antimicrobial properties. But after that, none of the hydrosols and none of the 10% essential oil solutions had zones of inhibition over 10 millimeters, and that the geranium hydrosol actually had a higher average of zone of inhibition compared to the 10% solution essential oil. Looking at figure 3, you can tell that before and after there was about a 13% reduction rate. However, when we ran statistics, we found out that the numbers are not statistically significant. If I had a similar opportunity to do this research again, I would definitely think of ways to quantify the data before starting the experiment. In my second experiment, the skin flora, we didn't think of that beforehand. So my first 2 samples, they were used doing a technique that couldn't really be quantified, and we realized that after we had done them and we came up with a new technique to quantify the data, which means I actually lost 2 samples that way. After doing this research and talking more specifically about the skin flora experiment, it raised one really big question for me. Since the lavender hydrosol reduced the total colony count by 13%, but it wasn't actually statistically significant, I'm wondering what the lavender 100% essential oil would do to the total colony count. And if I personally am not able to investigate this in the future, I think this would be a great pathway for future students to look at and not only use lavender 100% essential oil, but also find other essential oils that are safe to go on your skin at 100%. I think that would be a really cool research path to go down just because essential oils are so popular right now. Not so much hydrosols, but I feel like hydrosols will be on the come up soon. And for those students who want to take advantage of resources in a way that would enhance their research experiment, I would 100% encourage them to pursue GLD in undergraduate research. This gave me an opportunity to make my research my own, and I was able to do basically whatever I wanted to do with the okay of my mentors. It was a really nice way for me to be introduced into undergraduate research, and it really has me excited for what's to come in the future. One guiding principle I learned throughout this research was how to stay fully committed to something. When I first did the zone of inhibition experiment, the first round, I went to go measure the plates, and my mentor told me, don't expect big zones of inhibition. And when I saw the plates, their zones were very small. It kind of got me down a little bit because I was expecting to see large zones. Like I was really hoping for large zones because that would show that these have antimicrobial properties. But then I had to understand also that these small zones also showed something. It showed that they didn't have antimicrobial properties, and this is useful information for these manufacturers that make it, that say they don't have FDA approved statements. And this is an experiment, obviously I'm not the FDA, but this is an experiment that shows that maybe some of the things that they're saying aren't as true as what they should be. And I'm definitely going to carry that principle with me into whatever I decide to do, which hopefully is research and development with pharmaceuticals, because I feel like when you are developing new pharmaceuticals, you are going to fail a lot, and that might get some people down, but you have to stay committed because there will be a time where your medicine finally works, but you have to work to get there. You can't just give up after a couple tries. After doing this research, I realized that I wanted to learn more about other essential oils and other hydrosols, and if they have any antimicrobial properties. I think that would be something super interesting for me to look at in the future, and also future students to look at as well. Coming into this research experience, I was a little confused on what I wanted to do with my future career. I actually was a chemical engineering major for a very brief period of time, and I wasn't quite satisfied being there, but I also didn't really understand or knew where I belonged yet. So by doing this research and constantly being in the lab, researching things, testing things, I really found that I absolutely loved research, which I always have, but this was something different to me. I love testing the microbes and working with them and just seeing how they interact with other agents and what happens. And it made me realize that, maybe biochemistry is something I could do. So I actually talked to my mentor and another biology professor about it, and we kind of came to this conclusion that that would be a good area for me to go into when I'm older. So now, thanks to this research, I feel satisfied with where I'm at. And I definitely want to do research and development with pharmaceuticals when I'm older. And I'm so thankful for that.